Hi, welcome to the analysis.news. I'm Paul Jay. In a few seconds, we'll be back to discuss Chapter 11 of the IPCC report. It's written in a very scientific, precise language, but when you kind of get what it's saying, at least for me, it should scare the hell out of you. Be back in a few seconds. Please don't forget the donate button and the subscribe button, and most importantly, get on the email list, go to our website. Be back in a second. So as I was saying, the IPCC report, the sixth such report, it's done every 7 years, is a dire warning that humanity is on the road to a rather climactic climate catastrophe. That's not their words, but that's more or less what they're saying. Today we're going to focus on Chapter 11 in that report. And according to Chapter 11, climate change has already increased the magnitude and frequency, and I'm quoting here from the executive summary of Chapter 11, frequency of extreme hot events, and decreased the magnitude and frequency of extreme cold events, and in some regions intensified extreme precipitation events. So we're saying it's already happened. As the climate moves away from its past and current states, we will experience extreme events that are unprecedented, either in magnitude, frequency, timing, or location. The frequency of these unprecedented extreme events will increase with increasing global warming. Additionally, the combined occurrence of multiple unprecedented extremes may result in large and unprecedented impacts. This will be the case even if global warming is stabilized at 1.5 degrees. Let's repeat. These extremes that we're already experiencing are going to get worse as they get closer to 1.5. And even if we are successful at stabilizing 1.5, these extremes are still going to exist. But as we'll discuss later, and we've discussed in other interviews, the odds of us stabilizing at 1.5 are looking slimmer and slimmer. All right, back to quoting from the report. Relative to present-day conditions, changes in the intensity of extremes would be at least double at 2 degrees centigrade. Okay, get this. The extremes will double at 2 degrees centigrade, and a lot of scientists think we're already on the way to 2 degrees, even though people are calling for measures to stop that. But certainly if the status quo of climate policy doesn't change drastically, we're more than likely to see 2 degrees, and these extremes will double, but they will quadruple at 3 degrees of global warming. I'm back to quoting from the report again, compared to changes at 1.5 degrees of global warming. The number of hot days and hot nights and the length, frequency, and/or intensity of warm spells or heat waves will increase over most land areas, and the report has in brackets virtually certain, which it does throughout the report, depending on whether they're virtually certain or medium certain. But I think at one point in the report, when they're not virtually certain, it's usually just because they don't think they have enough data yet. The report in another place says new evidence strengthens the conclusion from SR 1.5, I guess that's the last report, that even relatively small incremental increases in global warming, that means half a degree centigrade, causes statistically significant changes in extremes on the global scale and for large regions. They're high confidence. In particular, this is the case for temperature extremes. The intensification of heavy precipitation, including that associated with tropical cyclones, and the worsening of droughts in some regions. And they have high confidence of all of these predictions. So even half a degree can have significant increases in these areas, according to the report. Now joining us to discuss Chapter 11 of the IPCC 6th Assessment Report is Zhubin Zhang. He's from Canada. He's also a coordinating lead author of that chapter, and the chapter is titled Weather and Climate Extreme Events in a Changing Climate. Shubin is a scenario research scientist with the Climate Research Division of Environment and Climate Change Canada. He served as a lead author for previous IPCC reports. He uses observations and climate model simulations to unravel climate responses to human activities, in particular linking human induced greenhouse gas changes in mean and extreme temperature and precipitation. He's been studying climate for more than 20 years. Thanks very much for joining us.
Thank you, Paul.
Before we get into the science of the report and the chapter you focused on, first of all, working on this over the years, seeing more and more data, getting a clearer picture of how dangerous the situation is. How does this affect you personally? Doesn't this scare the hell out of you?
When I started more than 20 years ago, I was not a firm believer about climate change. It's a young scientist looking at data, and the data shows something somewhere about changing the climate, but not always. So through the years, I see that the evidence just accumulating with the time and more. And when we look at more places, we just see many more kind of evidence. I'm not necessarily get scared, but what I see is that, yeah, it is here, it is everywhere, and it become a problem for us because we do need to think what we can do and how we can adapt to this situation. And in particular, we will need to think about how our future generation can adapt to this kind of situation. I mean, we certainly want to reduce the emission and to keep the warming as little as possible. But on the other hand, no matter what we do, we simply cannot stop it right away. So it is coming and even with a bigger uncertainty, bigger kind of intensity. Therefore, we need to think about to do something about it, adapt to it. It's not about I'm completely scared, but I know we need to do something about it just to survive.
And you are still hopeful we can. Your colleague from Switzerland, who led this chapter of the report, has been quoted in the press as saying that she's not so sure she wants to do another scientific assessment, be involved, because it seems like a waste of scientists' time, because the policymakers in governments around the world are doing so little that, what's the point of another report when they already have enough information that should have given them enough sense of urgency to do far more than they are? Do you have the similar feelings?
Well, if you are a doctor and if people don't want to do the vaccine, what are you going to do? You're going to tell them do it again, or just say, okay, I'm wasting my time, not going to do it. I think I certainly share her frustration, but as a scientist, we still need to do our job. I mean, we still need to communicate and to do our research to provide the best things to the government policymakers as well as to ordinary citizens. I mean, it's very similar the situation that we have compared with the pandemic. It's probably just many magnitude bigger. So simply people don't do action doesn't mean you should not be doing anything about it. I think that would be the kind of thing I would think.
Yeah, I saw another interview with her where she was saying she was mostly venting her frustration. She wasn't saying she never would do it again. But it must be extremely frustrating for you. And I take your point on the pandemic. Scientists have been predicting this pandemic for years. They've been warning governments to get ready for it. And next to nothing was done. But you're right. We can get through a pandemic. We don't get through the climate crisis if there isn't more serious action taken. Uh, is that true?
Yes, there's a big difference between the pandemic and the climate change. So the pandemic is something that scientists or doctors told us it's coming, and we are not really prepared because nobody is seeing it. Okay, so I think that to some kind of degree we can understand that part. But what is the real problem with the climate change is that we are actually seeing it, we are feeling it, and And then with pandemic, you get this kind of vaccine. When the vaccine is developed, you can really have you can have go through it relatively quickly. But with climate change, we are kind of like a frog in a small pot that's being heated, and the water is just slowly increasing. So when we are really feel it's so hot, we may not be able to jump out of the pot. We may just be cooked alive. So there's a fundamental difference between this climate crisis and a pandemic. That's the kind of I'm really worried about. That's why I feel it's the kind of action that, including the reduction of emission as well as adaptation, are huge, are urgently needed. Because once we really feel we are in big crisis, we need to do something, it may be a little bit too late for us to act. And the momentum of the whole climate change is just so big that we cannot easily stop it.
Some people think it may already be too late in terms of preventing reaching 2 degrees centigrade. Do you think so? That given government policy as we see it now, and it's unlikely to fundamentally change within, some people say we have a window up till 2030 to take radically different measures to avoid hitting 1.5 degree warming above pre-industrial temperatures. Uh, but some people think the way we're going, we are going to hit 1.5, and a lot of scientists and others think we are going to hit 2. Do you think there's still a chance to prevent that?
Well, the chance for us to go not too much beyond 1.5 is still there. There's still a relatively small window that we can really act upon very quickly. And but it does require a lot of action to reduce emission. It's not just something that announced by all the governments around at the moment. It's probably not that enough.
Some governments are still talking about reaching the measures of the Paris Accords, but I've seen a lot of the IPCC scientists have said even if all the governments actually achieve the Paris targets, we still hit 2 degrees, that the Paris targets aren't not nearly enough.
Well, the to stop the warming, we really need to have net zero. That essentially we need to stop increasing of the greenhouse gases in the atmosphere. And then in order to really make it even less, make it cooler later on, if we ever go beyond this Paris target, then there actually need to have a net reduction of the greenhouse gases in the atmosphere. It's a relatively simple physics or chemistry. You say that, so it's the balance of the conservation of the matter.
Now, between the last report, the fifth IPCC assessment, and this one, the sixth, what alarmed you the most over this last 7 years?
I think what really alarmed me the most is the is how much we see now, especially at the kind of spatial scale that is so small that we can see the changes in climate, and as well as in many aspects of weather and climate extremes. This is not completely unexpected, but to a large degree, we were expecting to see this kind of things 7, 8 years ago. But the fact that we are actually seeing it, we are actually able to see it and to validate what we were expecting several years ago, that sends a strong message to us that this thing is happening, it's here, and we need to do something about it.
In the report, you model what the weather might look like, climate might look like at 2 degrees and at 4 degrees. And I was kind of alarmed that you spent so much time uh, dealing with 4 degrees, because a lot of what I've read, at least 4 degrees, is a planet that's unlivable for at least half the planet, if not more. And even in the northern areas, um, where you could say there's still going to be life, there's going to be droughts and storms and fires, and I mean 4 degrees is pretty serious territory. But you spent quite a bit of time using the 4 degree and 2 degree. And when I asked you about that, you said, well, people can infer from that what 3 degrees look like. And I take that. But it also means the possibility of four is very real. Otherwise, you wouldn't spend so much time on it.
Yes, possibility is actually real for two reasons. One is that even though we collectively we have a understanding that a drastic reduction in the emission need to be done, but we as a scientists we don't know if that will be the case because it depends on all sort of things that we simply don't know what's going to happen. And that's one area. So what if we cannot reduce the emission by as much as we hope we can? That's one aspect. The other aspect is that the future projections also determined critically by what we call climate sensitivity. That is, how much temperature increase you will get by adding additional amount of carbon dioxide. So this is something that we have still some uncertainty or quite a bit of uncertainty. So this 4 degree will will occur if the climate sensitivity does hit to the kind of higher range, to the higher level as we still feel is feasible. So what I mean is that even we reduce the emissions to a great level, and because there is still aspect of such kind of possibility that temperature can still hit to a quite high level, such as 4 degree.
And just to dig a bit into the model, uh, you talk about a low with low confidence that there could be a triggering event. I don't think those are your words, but something that is significantly speeds this process up. Some people use the word tipping point, and that so that the idea that this would continue to be a gradual increase to 1.5 to 2 may not even be true. Something may happen that could actually precipitate some effects of hitting 1.5 even within the next 10 years or so, rather than in 2040, which I think is what is the generally thought might happen the way things are going.
Yes, this it's not a chapter that I mean we didn't spend a lot of time on a particular question, but there were several authors involved in that part of assessment, what we call low likelihood high impact event, and it certainly can happen if certain kind of condition met, and this is a kind of condition we just simply don't have fairly good kind of handle on at the moment. There are many things that we can think about that can make a huge differences. For example, like shut down a thermohaline circulation of the Atlantic, the kind of uh, energy transport belt in the oceans, you can say it in that way, that transports energy from the south to the north. If that changes or suddenly shut down, and that recently there's some kind of evidence that is slowing down or getting unstable, and that is one kind of factor that can cause a problem. And the other kind of thing you can imagine things like Greenland or especially Antarctic ice sheet. If they suddenly collapse and get in the ocean and melt, that will also cause lots of changes, not only in the sea level but also in other aspects of the entire atmospheric and oceanic circulation. So there are things that can cause this kind of a problem. And remember, this kind of a atmospheric oceanic this kind of situation, what we call is chaotic system. The chaotic system can move its own kind of particular trajectory, but at a certain point it can also jump into another trajectory. This is what scientists call a butterfly effect many years ago and developed by a famous scientist Collins. So certainly there's such kind of possibility, but Most of the assessment is not based on that. It is a kind of possibility that we feel that we need to bring into the consideration when decisions and policies are made. Because this kind of event, if it happened, the impact is really, really catastrophic to the point that it's probably beyond what we normally can imagine.
And you're not in the report. You're not saying such a thing is unlikely. You're saying there's not enough data to say if it's likely or unlikely.
Yes, what the report says is such a kind of a event is possible, but we don't have enough information to assess its likelihood or its possibility. You can say in that way.
Okay, you're in Canada, so let's start with North America. At 1.5, if I understand correctly, we're now at about 1.1 degrees, and we're trying not to get to 1.5. Supposedly, we're trying. I don't think we meaning the governments of the world, and that ain't me, aren't trying hard enough. But at any rate, what does North America look like at 1.5? What does it look like at 2?
Um, okay, so in general, like in Canada, temperature increase about twice the global warming rate. So, so 1.4 degree is about 0.4, now 1.5 degrees is about 0.4 degree higher than where we are now. And then you can imagine that at that point, where our temperature will be about 0.8 degree warmer than what we have now.
Okay, let me understand you're saying correctly. You're saying Canada is already a little warmer than the global average?
Uh, our temperature increase at about twice the rate of global warming rate. And
Why?
our Arctic region increase, I mean, the Arctic warms even faster because of reduction in the snow and ice.
Hmm.
Yes, we warm faster than what you think of the global warming because the oceans warms much slower than land. And also we are in a high latitude. Yeah, we warm more.
So what does Canada look like at 2 degrees?
2 degree, we are going to be 1.5 degree warmer than we are now. You will see a much drastic reduction in the snow. You will see you will see quite a bit increase in the heat wave and a drought and a fire, forest fire, and a wildfire as what we are seeing in the west. And then, importantly, if you are aware in east, in western part of Canada, lots of kind of water supply come from a glacier or the winter snowpack melt. And this kind of melting event will become much earlier. So if you look at the water in streams and rivers in this kind of west area that's fed by snow melt, you will get that much earlier, and which means that during summertime you will get much less water that you want. So there'll be quite a lot of changes, and it can cause a lot of problems.
Well, what's left of we're doing Canada, then we'll do the United States. What does that do to Western Canadian agriculture? Especially wheat, which is one of the most important pieces of the Canadian economy.
Wheat can be a problem in that when you have temperature increase, the growing season starts earlier, and then you need to seed the wheat earlier. And so what could happen is that when you need water, you may not have enough water. So even if you have temperature, you may not have the water. And if you really seed later, and then temperature will increase faster. So this kind of wheat or in berry, they stop grow when temperature hit to certain levels, say like 30 degree. Exactly, I don't know because I'm not working on that area, but I got impression it's around 30 degree. So if high temperature really gets hit sooner, which means that the growing season for this kind of crop will be shorter, and you would expect some kind of reduction in the in the crop yield for this kind of crop, unless the cultivar is changed to suit for new climate condition.
And the fires we saw in British Columbia this year, I guess that's just a taste of things to come.
I I I would think so. And we don't actually know exactly how the fire will change. But what we know is the weather, dry weather that's very, very conducive for fire will increase a lot. So so if you get lots of kind of fire weather, you certainly you probably want you would expect some kind of increase in the fire, both in the
And this isn't just about 2 degrees, which is really an extreme, although we're likely getting there. We're already seeing this at 1.1. So at 1.5, we're already going to see uh, a more extreme version of what we've seen this year, which means within 10 to 15 years.
yes, I would expect that we will be seeing more and more, and that is kind of things I'm seeing around the world. It's you know my work is not just about Canada, so I've done work in other parts of the world, and we actually seeing this. This is why in the assessment in some of your policy maker and even in our executive summary, there's a sentence called some recently observed cold extremes would not have extremely unlikely to have occurred without human influence. You know, the kind of like very, very extreme heat that we experienced in BC not long ago, and also the extreme heat that people experienced in Europe last year. These are kind of things that if we didn't have the climate change, if we didn't have this kind of warming, they probably wouldn't happen as bad as we have experienced. So we are really seeing it is coming.
Well, most of our audience is American. Uh, Give us a picture of what the United States looks like at 1.5 and then at 2 degrees. So let's start with well the same things. Maybe the West and agriculture and cattle and so on. Some people have talked about the U.S. at 1.5 and 2, that the Western U.S. starts to look like a dust bowl. Is that an exaggeration?
Uh, I don't think it's an exaggeration. And the drought,
You don't think it's an
no,
exaggeration?
no, no. We have pretty good understanding about what has happened and what's going on and what will happen. It's actually relatively simple physics. So it's going to get very hot. It's going to get very hot, and there wouldn't be much increase in precipitation, and quite likely there may be actually a decrease in precipitation. So in the west, especially in the southern part of the U.S., you have the increase in temperature, which is it's what we would say is virtually certain. And then you also have a pretty good chance that the precipitation will decrease. And then, it doesn't really take a rocket scientist to figure out that when you are sitting above a stove, you are having less water. What's going to happen? You get hot and dry. So it's very, very simple actually. So it's not about scary anyway. It is just what's going to happen.
One of the things you point out in the chapter is the role of urbanization. And I don't know that people have talked about this that much, that I've seen at any rate. But as hot as it's going to get, it could get much hotter in the cities and at night because urbanization increases the heat effect. And what does that mean in terms of the amount of air conditioning, electricity? And we already see brownouts often when it gets really hot. And there's not enough power for air conditioning. We can be imagining that in the next 10, 15 years, in big cities, it gets much more heat and a breakdown of the ability of the power grid to support the air conditioning.
Well, yes, if the power grids are not upgraded to meet the new demand, and yes, if the air conditioning technology is not hugely improved, and yes, if people continue to expand cities and build the city in a way that we have built our cities with all this kind of countries and other kind of means. Of course, there are other kind of aspects people can think about. You can think about building a city that is kind of more urban friendly in the sense that, for example, people are talking about green roofs, that kind of aspect that might reduce the heat trapping in the cities. Or you can think about other kind of things that such as a sponge city that can help you to help the water to the precipitation penetrate into the soil and reduce the flooding. So there are things people can do, and there are lots of things that if we don't do it properly, we will be just really going to get the bad situation even worse.
Yeah, because the more demand on the power grid for air conditioning, the question obviously arises: well, how are you generating the electricity? And if there isn't been a massive change to sustainable energy, it means there'll be even more use of fossil fuel to cool the cities down, which of course exaggerates the problem even more. Um, I mean, all this points to the irrationality of government policy. And I don't know if there's any government on the planet that's exempt from that irrationality, or should I use the word denial? You were comparing this before to pandemic. You know, you have pandemic denial, vaccine denial, uh, even governments that accept on the face of it, or at least in language, accept the science of the IPCC reports. The policy that evolves is as if they didn't ever see the report. We go back to your colleagues' frustration. Now, I don't know, you work for the Canadian government. I don't know how much you can say specifically, but it's not like the people not just in government, in the elites who have the real power in the financial sector and otherwise. They see these reports, but they seem to continue in this bubble of denial.
There are two different kind of aspects to me, and of course I'm not a policy analyst, so I cannot really say a lot about policy. But if you look back on a history, no matter who governs, sooner or later, policy will need to be governed by science. Because if you don't follow it, you are going to be hit, and you are going to pay the price for it. So I think people at a certain point, sooner or later, will learn that what is the right thing to do and what is not the right thing to do. So following science, following the guidance of the science, I think is the only way for us, for humanity to move forward. And I think the human history is that we are pretty good at doing it, even though sometimes we pay a big price to learn before we actually do things right.
Yeah, that's the rub with this climate problem. Is in terms of human history, we kind of had thousands of years to work stuff out, even as stupid or short-sighted or whatever. Yeah, humans usually got it eventually, but this is a problem we don't have eventually. We don't have thousands of years. Like it's now. I can't say it's now or never. I guess there'll be some humans left at the end of all this. But in terms of organized human society, it's now. We're in the decade where if we don't make the changes now, the 4-degree level is probably inevitable by the end of the century, and maybe even sooner, the way things are going. I mean, I'm not exaggerating, am I?
No, you are not. You are not exaggerating. Yes, we do have to act now and quick and big. That's the only way for everyone to get out of this crisis, to really, really, and for the sake of our future generations. That's the only responsible way for us to be human beings, I think.
Okay, so if I understand it correctly, you grew up in China. In fact, you did most of your education in China. You did your master's degree to China before you moved to Canada. I know on this IPCC report, many Chinese scientists have been involved, and you know many of them, and you've worked with them. What's your sense of how serious the Chinese government is about addressing climate. A lot of people think that China may be in a better position to do something because of a planned economy to some extent and the ability to, push things more quickly than perhaps in the United States. On the other hand, China's use of coal is increasing. And some people are saying the argument that coal is only a transition uh, doesn't sound legitimate because there isn't a fast enough move to solar and wind, even though China's more advanced in solar and wind, especially solar, than most other countries. But the sense of urgency doesn't seem to be in China either. And when it comes really to what's being done, what is your sense of what China's approach is?
My sense is that they consider this climate change is a real problem for them. That's my sense, and they really want to do something about it. They want to get into the carbon neutral. They want to cut emission, and I certainly see action being taken, a lot of action being taken there. And for example, I visited my hometown not long ago. I mean, a few years back, and it was a very very poor area when I left. To be honest, at the time when I left, many people in our area probably still didn't have enough to eat. So that's the kind of living condition we went through. But a few years back, when I went there, revisited that, I couldn't recognize anything. There's a very, very kind of a high speed railway transportation system. And this kind of a windmill was just everywhere. That was very, very astonishing to me because I was not expecting that. And then I did have friends who work on these kind of things, and they told me that they lose money by installing more windmills. Every windmill they install, they lose money. But government insists that you need to have certain amount of power generated by wind in order for other kind of things or other fundings you can get. So from that, that's a quite low level of operations of the government. It's not from central government. It's quite a local, like here, more like in community level. So from that, I do sense they are very serious about it. But of course, China has a huge population. They are still growing quite rapidly. They have more kind of energy demand issues than many other places. So how much they can do, how much they can afford to do, that's another question. That's a different question. But I do see the urgency and also the kind of strong pressure from the top that something needs to be done. So what I feel is that all this kind of high pressure about reduction of the emission through really, really top of the government will translate into action, including new scientific innovation. I'm quite certain that will come, even though I cannot predict how fast it will be. But you know that in China, there are many, many people, not only just the general population, and there are also many, many smart people who are very innovative. So I think they will find some solutions. So the thing is, there is a huge political will to do something. And the Chinese system is that if at the very top there's a political will, if people underneath don't follow, don't produce, they will be personally liable. They can lose their position, so on. So I think it's real. They are serious. That's my sense.
And that's rather significant. I think the Chinese economy produces 30% of global emissions. If I'm right about that number, it's rather. I mean, if China and the United States don't get their act going, it's not going to matter too much what the rest of the world does. Well, I don't know if you can comment. What do you make about current American policy? Certainly, the language has changed since Trump. There's some initiatives that seem real, but there seems to be so much emphasis on carbon capture and carbon sequestration and certain amount of technology which actually doesn't seem developed, certainly not developed enough to make a difference in 9 years, but by 2030. What's your take on that?
Well, it's this kind of a carbon capture kind of thing is really not the kind of subject I work on. But if you look at the politics in the states, if you look at how they deal with the pandemics, I don't know how much confidence you have when it comes for them to deal with the climate change.
Hmm. Yeah, that's a good point. If you can't deal with vaccinations on a national basis, how are you going to deal with climate when half
Yes, that's
the
my
same?
point. So
Yeah, that's a rather terrifying point, which leads one even more to the conclusion that we are on our way to 2 degrees, 3 degrees.
but
All right. Well, listen, that's good for today. Thank you. I will come back to you again, and we'll dig into some more of the particulars if we can.
sure, thank you.
All right. Thanks very much for joining me,
Thank you.
and thank you for joining us on the analysis.news. Please don't forget the donate button and the shares and the subscribe and all the rest.